All right, for number 30, I gave you the first term already, was 3. Do you guys remember how to use the recursive formula here to find the other terms? Do we remember what this little notation meant back in the day? A with a subscript of n minus 1. Previous term, yep. All right, so please hold my hand through this. How do I find the second term? 1 plus 2 times, what do I plug in now? Y3? It was the previous term, yes. Boom, 3. Second term is 7. Got to find the first 4, though. How about the third term? Same thing, right? 1 plus, now I'm not going to do 2 times 3, but 2 times. Yep. Which will be 15. And finally, the fourth term. 1 plus 2 times 15. Final term here, 31. So you guys have 3, 7, 15, and 31 for your first 4 terms. All right. We are right there. All right, second part. Can this sequence here be represented using an explicit geometric? Anybody want to fill me in? What did geometric mean again? Oh, come on. My heart. It was arithmetic, and then there was geometric. Anything. 26 points. That's what we need. Geometric, you had to. Oh boy. Now I'm nervous. Multiply, right? Arithmetic, you had to. Add, yep. So here's what it's asking. Is this sequence 3, 7, 15, 31 geometric? Are you multiplying by the same number to get to the next one? And a lot of you are shaking your head no, because you can't think of a whole number that you can multiply by, but you never know. There might be a decimal or a fraction that you can multiply by. I don't even know why I'm asking this now. I know the answer, but do you remember the trick to find out what number you could be multiplying by if you can't figure it out right away? Anybody remember that one? Take a term and divide by the previous term. All right, so everyone ready? Take a term. Somebody, please, you can answer this one. Take a term. 7 divided by 3. You get about what? 2.3 repeating? Do I multiply 7 by 2.3 and get 15? You guys got the calculators. I don't. Yes, no? You don't, right? So is this geometric? Not geometric? Because you don't multiply, because you are not multiplying by the same number. Multiplying in geometric. Ooh, that was a 50-50 one right there. Decent on the top and then just a mess on the bottom. We all right here today? Don't give me this Friday business. I don't care. We're less than 3 weeks away now. 29. Now we're just going to be miserable now once you know what we're going to end up doing here. Miserable. Little dividing. 2 ways you can divide. We can do long division, or we can synthetically divide. Honestly, I know what you'd rather do. Personally, though, I'm not a big fan of synthetic division when I got a number out in front there. Okay? because then you're going to put a little 2/3 in that box, and whoa, no thanks. All right, I only like to deal with whole numbers when I synthetically divide. So yes, we are going to do some long division here. And it's not too bad because it's only a 2-pointer, so it shouldn't be too bad. Well, do we know what I mean by long division here? Get the old, I'm going back to elementary school here, the old house. Yeah, anybody? House, yep. Inside goes 6a to the third plus 11a squared minus 4a minus 9. And on the outside, hey, this test is tricky. It doesn't happen here, but take a quick glance. Anybody remember last year you had to make sure all the exponents are represented? And if there's not, you had to plug in a 0 for it. So just because 3, 2, 1, I got them all here, but I just give you this right here. I got to put in 0a squared. Okay? And same thing when you synthetically divide. All right? Questions? Yeah, back there, JT. Correct, minus 0. Correct. Even the number's got to be there too. Yep, good question. All right, let's divide 3a into 6a to the third. What do I have to multiply 3a by to get 6? Well, let's start with the 6. So I got to multiply by 2, a to a to the third. A squared. Now I'm going to multiply. And what I'm going to do is basically take 2a squared and multiply it with 3a minus 2. Whether you do that right here or off to the side, it's up to you. So we end up with 6a cubed, which is what we wanted. Ready? And minus 4a squared. Everybody good? All right, now time out. Hold on. Let's get everyone caught up because there's a little change up here. These aren't going to cancel out. They're both positive, right? They're both positive. So you have to remember when you write this, you are actually subtracting it all. That's how you get everything to cancel out. So you're not really doing 11 minus 4, are you? You're going to do 11 plus 4. So this term will be 15a squared. And then bring down the next term, minus 4a. All right, remember that. You got to change the signs. Long division only. All right, you're up now. 3a times what gives me 5a squared? All right, 15a squared. I already kind of gave that one away. Plus 5a. Go ahead, 5a times 3a, 15a squared. That's what I wanted. What's the next term, though? 5a times negative 2. Minus 10a. But remember, switch the signs. The 15a squared, see you later. What am I left with here now? 6a, because that's positive 10a. Bring down your 9. All right, one more trip here. 3a times what to get to that 6a? Dig deep. 2. So plus 2. Same thing, go ahead. Distribute. So I got 6a here. What's my number now? Minus 4. But your remainder is not going to be negative 13, is it? It'll be negative 5. There you go. There's your remainder, negative 5. All right, now how do I write this as my answer? Ready? 2a squared plus 5a plus 2, and then what are you doing with that remainder? Minus 5 over what's outside the house? 3a minus 2. Long division. How's that look, Ian? Why do I even bother? You're just so focused. Any other questions there? Long division? Good times. Good times. How about 16? Ooh, I should probably have the answer already there. A little multiple choice. This is where we're going to win the game, right? Multiple choice. This is where you're going to take your darn time. On the 24th, take your time here. You got to get 13 of them. 13 of them. All right. Fourth degree polynomial. There's the zeros. -5, 3, I, and -I. Which graph represents it? Can you guys eliminate two of them right away? If -5 and +3 are zeros, roots, solutions, which one are you going to get rid of? 3 and 4. See you later. Those are the opposites of what I needed. Nope. Nope. All right, now I'm down to 1 and 2, 50-50 shot. But we're going to actually get 100% here. Whew, which one am I going to go with here? Oh, I got a 2. Okay. Other than -5 and 3, what are the other two roots? Imaginary. Imaginary roots don't cross the x-axis. Only real roots do. Okay? Only real roots cross the x-axis. So yes, you're correct. 2. Only real roots cross the x-axis. Imaginary roots do not. All right, nice. Not bad. Quick. Dom, you right back there? Good. Can I get a score prediction, or you don't want to reveal that? Nothing? Pass? Okay. All right. Okay, you got it. Number 6. Something we just got to talk about because you haven't talked about it since last year. Which one of these is an even function? And you're not picking the one that has the most even numbers. Okay, let's not go there. I'll open it up to you before I tell you. Anybody remember how to show it's even? If you look at the graph, how to know if it's even or not? Going, last call. All right, if it's an even function, graph is symmetric. Oh, anybody yet? Anybody? Symmetric with? Okay. I tried. The y-axis. The y-axis. Meaning, flip your graph over the y-axis, it matches right up. So I'll give you guys know how to get the absolute value? It's either alpha window for most of you, or you can go under the math and go over the number on top. Math, number on top. Or most of you can just go alpha window. But okay, so go ahead, see which one I can flip over the y-axis and they match up. Remember, if your window's still in the window we used yesterday, make sure you go to Zoom Standard to get it back to the regular 10 by 10 screen. Finding it? Which one I can flip over the y-axis and it matches up? What are we looking at? Or is somebody having a problem graphing one of them? Your problem with number 2, or do you think that's the answer, JT? That is the answer, yes. Anybody having a problem graphing sine? Remember, you got to be in radians if you want to graph cosine. I got to be in radian mode. Are we all good there? Anybody want to ask anything else here while we're here? I thought somebody might want to chime in and ask something before I move on. You're not interested in something else? Thank you. Thank you very much. How do I know if it's odd? Because it could be even or odd. Symmetric with the origin. With the origin, not the x-axis, the origin. And I'll show you what I mean here when you guys just copy that down. I'll show you a graph. Can you guys go to your y equals screen, clear out anything that's there, and graph x to the third? And that's a graph that's symmetric with the origin. Take a look at it. Okay, everyone good? X to the third. So here's the, you ready? You try, I know it's got tough, but you pick any point here, go through the origin. It's got a point on the opposite side. So this is symmetric with the origin. Okay. All good? Good question, Morgan. And one more together. I might as well just go total beast mode on you before we go into the weekend. You do some on your own. Number 30. 33. I think I changed that in the back, huh? 33. Solve for x. And it says algebraically. Anybody want to remind me, even if I'm very, very desperate come game day, what I cannot do? Yeah, I can't guess and check here. All right, what's your first move here? Anybody? Or just throw stuff out. Even if you're wrong, who cares? Go, yeah, all right, distribute, go. Let's clean this up a little. Go ahead, distribute, clean it up. Yep, and let's keep cleaning up that right side. And I don't know if anybody's wondering, but you cannot combine the 2x and the x on the left side. One's underneath the radical, one's not, so can't combine them. Next move. Get the x over, yeah, because you want, if you're solving a radical equation, that radical's got to be by itself before you do anything. So yes, get the x over, subtract it. Nice job, everyone. Nice, we're moving smooth. We are smooth here. Making up for that sequences question. Okay, radicals by itself. Hi, Langston. Just wonderful. How are you? We're ready to, now that the radicals, it's got to be by itself though before you go to square it. Square both sides. Woo-hoo. And all squaring does to that radical is make it disappear. That's it. What's underneath does not get touched. 6 minus 2x. Oh boy, come on now. I stress out every time that you have to do something like this. How are you going to tackle this? Just double distribute, FOIL, whatever you called it back in the day. X plus 21, x plus 21. Excuse me. That's garbage. What are you guys getting in the middle? 42x. And one large number at the end, huh? 420. I heard it. I heard you. I get it. I heard you. All right. You guys have, I haven't done anything here, by the way. I haven't done any teaching yet. Next. Get everything to one side, equal to 0. Yep. How do you move the 6 over? Subtract it. How do you move the 2x over? All right. Add it over. Subtract the 6 over. So let's see. I'm going to have x squared, not 42 anymore, but 44x. And I'm not going to have 441. I was going to have 435. You guys are taking this all by yourselves. What's next? Try to factor it, right? All right, now look, I don't have the time to do this, but if you're really nervous come game day, you can always bust out quadratic formula and solve it using quadratic formula. Okay, if you're nervous. All right, I just don't have the time to do quadratic formula right now. So yeah, I am going to force you to find two numbers that multiply to what? This guy, 435, and add to 44. Your ninth grade teachers back in the day tell you the little y equals trick. I'm not a big fan because it's a trick, but all right, but you guys that don't know, you go to y equals, you type in the number that you're supposed to multiply to, so in our case 435, and divided by x, and then you go to your table of values and you find one that'll hopefully bring you to 44 somehow. So you can disregard all the decimals. Which one's going to bring us to 44 somehow? Those numbers that'll bring you to 44? 29 and 15. How about some signage? Both positive. One answer, x equals negative 29. The other one, x equals negative 15. You guys did a great job on this one. Great job. It's a 4-pointer too. I don't know about them. Because 12 days wasn't enough vacation time. That was a 4-pointer right there. Including me, we just got 3 points. At the very beginning of the problem, this equation we needed to solve had a radical in it. Anything that's got a radical, we have to do what with our answers? Oh, no. We don't have to do plus or minus, no. If we ended up taking the square root, it's plus or minus, but check your answers. Because most likely, especially on a 4-pointer like this, one of these bad boys is not going to check. Okay? What's that? What do you mean? Well, you couldn't just randomly guess negative 29 out of nowhere. You need to just see how you got it. But now you have to actually check that negative 29 works. So everyone store it in for x. Store in negative 29 in for x. Do the left side of the equation. You're going to get a number out. Do the right side of the equation. If those numbers match, it's a good answer. If it doesn't, we're rejecting it. We did all that great work and got to check it if it involves a radical. Got to check it if it involves a radical and you solve for x. And you let me know. One of them I don't think is going to work. Because the left side and the right side don't match. What'd you find out? Which one didn't match left and right side when you stored it in? Negative. 29 didn't work, right? So, fellas, like some of your dating lives, we have to reject it. Okay. Okay, we're okay there. All right, so just keep try to. I know we're throwing a lot at you, 1.5 years worth of material, but any radical equation, got to check your answers. All right, ready for the ones you need to try? Only a couple here today. I'm not asking for a lot. 34, 1, 2, and 8. You might want to get out your reference sheet that you're not going to be given to do number 34, because look at what it is right away. Yeah, confidence interval back in the day, about a month ago. All right, on number 34. I'll walk around helping you out. You guys know, let's go get answer keys open, please. Let's go. Phones, as long as you're using it for Aspen. Laptops, let's get them. Let's get them. On that sheet you're not going to be given, I gave you the formula how to find the 95% confidence interval. So that's on there when you have to find it, okay? But I'll walk around, help you out. If you want me to look at something, you know I will.